In this video, I will introduce the basic concept of linear function. So speaking of linear function, it is a good idea to compare the difference between linear equation and linear function. So let's start on the left, the yellow handwriting. We have linear equation. So let's say we have a linear equation y equals to 2x. The x, we call that an independent variable. The y, we call it a dependent variable, y. So let's say x is equals to 0. So you plug in 0 to x, then you have 2 times 0 plus 1. 0 plus 1 is equals to 1. So y is equals to 1. We say y is an dependent variable because the value of y depends on the selected x value. So if you pick another x value, so let's say x is equals to -5, then you have y equals to 2 times -5, which is -10 plus 9 equals to -1. So y is equals to -9. This value depends on the selected x value. So for x, you can choose whatever you want. So x is called an independent variable. So since the value of y is dependent on the value of x, so we call y a dependent variable. So let's look over to the other side, the linear function, the pink handwriting. So what is the difference between a linear equation and a linear function? So the difference is, do you see that there is an f of x? So when you write a linear function, we don't use the y anymore. So instead of y, we use f of x. So yes, you're right, f of x is just like y. So f of x is just like y. So f of x, that is not f times x, that is called f of x. So f of x is read as f of x, not f times x. So in a linear function, x is still an independent variable and f is the name of the function. You don't have to call that f of x equals to gx plus 1. You can call that a gx equals to 2x plus 1, or you can call that kx equals to x plus 1, or you can call that wx equals to x plus 1. So f is only a name. So when you take a statistics class, most of the time the textbook use f of x. So most of the time they use f of x. Of course, if you take a higher level of algebra, pre-calculus and calculus, so they use f of x, g of x, so on and so forth. But this video is designed to introduce linear function to give you the basic concept. So when you encounter function in statistics, you know what to do. By the way, all the keywords are underlined using my highlighter, and they are the words that you will see in statistics again. The word function is a very big word in statistics. So when you take a statistics class, you will see function all the time. All right, so now after you watch this video, when a textbook say function, you know exactly what it is. All right, so let's move on. So f is the name of the function. So let x is equals to 0. So do you see that inside the parenthesis, I already replace x with a 0. So that means on the right hand side of the equation, on the right hand side of the function, which is the body of the function, you have to replace the x with 0. So before you replace the x, do we agree that the math is supposed to be a 2x plus 1? How do you plug in 0? So all you have to do is you pick up an eraser, you erase that 0, and you erase the x and then replace that with a 0. So 2 times 0 plus 1, the y is equals to 1. So when x is equals to 0, y is equals to 1. After you perform this math, you get an order pair. X is equals to 0, y is equals to 1. If you look over to the left hand side, you get the same thing, right? So when x is equals to 0, y is equals to 1. What about x is equals to -5? Then you have 2 times -5 plus 1, that is a -10 plus 1 equals to -9. So you obtain an order pair or point where the x coordinate is -5, the y coordinate is -9. So if you look over to the other side, you perform the same math. X is equals to -5, y is equals to 9. This is an order pair, which is a point on the graph. And then speaking of function, two words that you will hear all the time. The first word is very important, is domain. Domain means the input of a function. So every time you input an x to the function, the x is your domain. So simply speaking, domain is the place where x lives. If you try to look for a definition of domain online or on any textbook, they usually give you a pretty complicated definition. So simply speaking, just make the language simple. Domain means the place where x lives. So in a function, you have f of x equals to 2x plus 1. So x can be some value, right? So whatever x can be a bunch of different values. So those value, we call it a domain. So that is the place. It's like a box where you put the x value in there. So imagine that you have a box. You put all the x value in there. So that box is called a domain. It's a place where x lives. It's the place where you put the x in there. So in simply speaking, domain is input. Input means x. All right. What about range? Range is the output. So every time you put an x into the function, you get an output, right? So back to the two math we just did, we put an x in there, we get an output. So x is the domain. The output is y equals to 1. So y, the 1 is my range. And then in the second line of math that we perform, we let the domain be -5, and then the output is -9. So you put one number in, and then you obtain one number. So you put one stuff in, and then you obtain an output. So input is domain, output is range, or you can say domain is x, range is y. All right. So what about the domain and range, and then the function? So how these things works overall? So the best way to understand how a function works is you consider function as a machine. So remember, a function works like a machine. So let's say we are talking about a vending machine. So what is a vending machine? You go to a big shopping mall, you see a vending machine, there are drinks in there, right? So you have Coke, 7-Up, whatever you like to drink, and then there is a price. You put the money in, and then you select that drink. Once you click that button, and then the machine will do the job, and then will give you an output. So the money, so look at the stuff I wrote there. The input is x. The body of the function, I use the function on the previous page, which is 2x plus 1, and then the output is y. So input, the x is your money. So you put some money into the machine, and then you press a button. You let the machine do its job, and then the machine will give you the drink that you have selected. So let's say x is equals to 6. All right, so x is money. You put some money into the machine, and then you press a button. So what goes inside the machine? What action are taken inside the machine? So let me fill up the machine for you. So inside the machine, so what it does is they take your inputs, they multiply the input by 2, and then they add 1 to it, and the output is equals to 13. So you input 6 into the machine, you press a button, and then you let the machine do its job, the body of the function, 2x plus 1. So it will double up your input, and then add 1 to it, and then your drink is the output, which is 13. So x is equals to 6, y is equals to 13. So you put 6 into the machine, you press a button, you let the machine do the processing, and then your output is 13. So the function works like a machine. You put one thing in, you get one thing out. The input is domain, the input is x, the output is y, the output is range. And then the body of the function, whatever the function is how is the action behind inside the machine, the actions taken inside the machine. So that is the easiest way to understand domain, range, and how function works. All right, so let's do a simple example on the next page. So I have a function. The function is f of x equals to 2x plus 1. Yes, we use that function again. So in this function, I give you some x value. I want you to put it in. You process the x value for me, and then you give me an output. And then after we finish the table, we would like to use the table values to sketch the graph of this function. All right, so when x is equals to -4, so you double up -4, and then you add 1 to it. So that is -8 plus 1, which is equals to -7. And then we got an order pair, -4 comma -7. And then when x is equals to -3 plus 1, so you have -6 plus 1, that is equals to -5, -3 comma -5. Double up a -2, add 1 to it, so you have a -4 plus 1, that is equals to -3, so you have -2 comma -3. You double up a -1, you add 1 to it, so that is -2 plus 1 equals to -1, then you have a -1 comma -1. 2 times 0, you add 1 to it, 0 plus 1, then you get a 1, then you have 0 comma 1. 2 times 1 plus 1, you get a 2 plus 1, that equals to 3, and then we have 1 comma 3, and then 2 times 2 plus 1, 4 plus 1, you get a 5, then we have a 2 comma 5. And then the last thing, 2 times 3 plus 1, you have a 6 plus 1 equals to 7, so you have a 3 comma 7, and then you plot these points. The first point is -4, -7, so -4, -7, and then -3, -5, and then -2, -3, and then -1, -1, 0, 1, 1, 3, 2, 5, and then 3, 7. So do you see that if you trace the slope, m equals to rise over run, what is the slope? So here is the slope. So you grab a point, so you take 1 unit to the right and then 2 units up, right? So the run is equals to 1, and then the rise is equals to 2. So overall the slope is equals to 2, and there is a y-intercept. Y-intercept at where? At x is 0, y is equals to 1. So using the point slope form, we write y equals to 2x plus 1. For a function, you replace the y with f of x, that is equals to 2x plus 1. Of course, the graph is not done. You have to use a straight line to connect all the points. Then there you go. So what is this line represent? This line represent f of x equals to 2x plus 1. And what does the graph trying to tell you? The graph describes the behavior, the overall behavior of this function. So using even easier language. So let's back to a table. We take a step back. So back to a table. So this is like you are standing on a parking lot. You are looking at a bunch of cars, right? So let's say you go to school, you just park your cars, you get out of your car. What do you see? You see a bunch of cars around you, right? So that is the table value. You see a bunch of order pairs. But if you cover up the graph, you just look at the table value, you don't really see how what the line is, right? Of course, if you are very good with linear function, of course you know that it's a straight line, the slope is going uphill. But what if I give you more complicated function? Then you don't know the shape of the graph. Okay, so now you plot all the order pairs on the xy plane, and then you connect the points. Now you see the overall behavior, you see the overall pattern, or you see the shape of this linear function. So what is this? How do I use a few words to describe the picture? So using a table value, you are standing on a parking lot and then looking at a bunch of cars, right? If you have a picture, that is like you go into a building, and then you take the elevator, go straight to the roof, and then you look down to the parking lot. Now you see every single car in the parking lot. So that means if you do this, you will see the overall picture. You see the big picture. Okay, so that is how a function works. Again, x is input, is domain, and then you input an x to the function. You do the processing, you do the plugin, perform the math, you get a range, and then the domain, the input and the output gives you an order pair. You plot all the order pairs, connect all the points, so you will see the overall pattern of the linear function. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment section below. Please like the video, subscribe to my channel, share the video for me. I appreciate your help. I will see you all in the next lesson. Signing off for now.